Today I'm going to try and give you a broader sense of Async and the underlying concepts that it represents and implements for the Python programming language, as well as I'm going to hopefully show you why you would want to use it and why you wouldn't want to use it. Like every great tool, every great library, it is not it's not the hammer for every problem. It is a really great tool that opens a lot of possibilities for you, but it is not the only tool, and it's probably not even the tool you want to use for every situation. But we'll get more into that as we go. If you're curious more about the Python implementation of Async, you can read up on this. All this is in the standard documentation. Likewise, I can attach a few links to better explain it. But here we go, diving right in. So, when it comes to making requests over any kind of outside process, and process meaning, another program running, even if it's on the same machine, you can't talk one-to-one as if it was in the same memory. So imagine there's a box, and each program runs its own separate box. Looks like a goalpost here. When each one of those boxes need to communicate with each other, they have to set up some kind of outbound connection system. Why that's important is because in the case of, say, an API, that's really all that's happening. There's a lot of nuance with how we make that connection, but at the end of the day, we're turning something into a format that can be shipped over some kind of external transport, even if the external transport is still just on our machine. And the issues with that is that you're not doing computation. You're not doing hard math problems there. You're kind of sending something over and waiting for a response. So in traditional programming, they would just stop the program. You would wait for your response to come in and then continue on. However, this is not very efficient, especially when you're running tons of requests, tons of IO bound operations. So the idea of having a thread, which is just CPU's, not even CPU, in this case the operating system's unit of execution, just dedicated directly to waiting for something to come in. The idea with async programming is that you treat everything as if it will eventually arrive, but you don't make any guarantees of when that happens, and you build constructs to switch in between a various tasks, while all these tasks can theoretically run on the same thread. And this is very important for Python because, as you know, there is this thing called a global interpreter lock, and it makes multi-threading in Python more or less impossible in the true sense, because at no point can more than one thread run. Asyncio takes that and spins it where it turns everything into a task-like object, and you can stop and start them, and you can also switch between tasks. And when you have one thread and one of these task blocks, you can simply switch to the next task, and once that block, switch to the next task. And it kind of becomes this repetitive cycle where at no point is the thread waiting or idle. and it makes the utilization of a one thread super performant. And this is very similar to how Node.js does it, how C# does it, how Rust does it, and several other programming languages that I'm not even mentioning right now. And this whole concept is based on the event loop pattern, which this is Python's implementation of it. It was, there are many of them, and probably the most famous is the Node.js event loop, which more or less inspired this one. So, to get into the meat of what we're going to do to kind of prove this out, we're going to be hitting this API, which if you haven't used it is really cool. You just need to set up a token, and if you want to support them, they have a Patreon, but they have a vast amount of data that you can use, and especially if you're a movie buff and love this stuff, it's a great tool. In addition, we're going to be running 3 programs, one being sync-HTTP, one being async-HTTP, and one being performance comparison. And all 3 of these are going to help us demonstrate why you want to use Asyncio. This project will be linked in the show notes, as well as like how to set it up. This is using Poetry to just set up your virtual environment and install all the dependencies. I'm kind of new to Poetry, so if there's something weird that I did, just give me the benefit of the doubt. But here we go. So first, we're going to run the sync-HTTP, which we have our logging. We have the standard Python request library, which just runs just HTTP requests back and forth, and we're returning the JSON results. This is all running off of user inputs that will pass in here, and you will need your token to be able to run this. And we're using this thread pool executor, which is basically just the Python, a Python thread pool. But basically, it is Python's answer to multi-threading and reusing threads within that. And we're going to be creating a bunch of Python futures. All of this should be very similar to the Java API if you're familiar with that. If not, just know that we're spinning up a bunch of threads and waiting for the results. So here we go. And we're asking for a token, paste it in, and we're going to do movies about monster singular. And we get a bunch of responses. You can see here that it is a lot of info, and we're not really doing much with it. But, this shows that you can use multi-threading to kind of help with making a bunch of HTTP requests. And to clear that. So that was the sync example. Let's go to the async example. So again, we have logging. Asynchronous, we have to use a special logger because we don't want to block. And this is using the AIO HTTP library. And it's basically a new Python request alternative for asynchronous programming. Some of the issues with using request in Asyncio is that it doesn't support it. And it's mostly using threads to do the kind of, handoff of, the HTTP transmission. Asyncio uses the Asyncio library and builds on top of it to support HTTP. And this kind of gets into one of the problems. There's kind of this, in the async programming paradigm, there's kind of like this red function, green function. I'm probably messing this up, but the general idea is that a red function can only call another red function, and a green function can only call another green function. So when you use asyncio, you are going to be all in on Asyncio from top to bottom of your application. You more or less need to use it. You can kind of come in and out of the async space with some tools. Particularly, you could do this loop run until complete. The problem with running this, though, is that every time you exit the async part of your application, you get a penalty hit. And every time you enter async part of your application, you also get a penalty hit. So the transition between the two is not seamless. So if you can, try to do everything in Asyncio if you're using Asyncio. If you can't, you might have to consider another program paradigm to support your needs. But again, this is doing the same. It's just spinning up a bunch of these async calls. There's no executor that we're using here, and we're waiting. And you can see any async function, method, whatever, has to have this async definition in part of its signature. And what else? I think that's it. We can just run this again. So here we go. Oh, no. I ran the wrong program. So here we go. Token, monster singular, and we get results. Nothing really exciting is between the two, and that's kind of a good thing because at the end they both achieve the same results. What we're more concerned about is the performance of the two of them, and that becomes super important because in an asynchronous microservice kind of world where we have cloud and everything else, the more performance you can get and the more utilization your app has of its resources, efficient utilization, not just spinning threads for fun, the better your overall experience is going to be, and the better it is for your cost, your users, and your company. So this is a comparison. It should be pretty straightforward. We're doing more or less the same thing, just re-implementing the code in the sync and the async, but doing them in a more comparative way. And we're going to basically be running these one after the other and capturing the start and end time, and then pumping all this info into a pandas data frame and getting the mean runtime. To preface, I'm not a professional statistician. Take any results that come out of this with a grain of salt, but it's a pretty well observed pattern that asynchronous applications perform much better and just better utilize resources. So you can look up a proper statistician's evaluation of this, but we're going to demonstrate it all the same. So we're going to run this. We're going to paste this. And our monster. And we have our results. So this is a pretty dramatic comparison between the two. You know, the mean time, I believe this is in seconds. So on average, you know, this is less, the average run of the request among all these, like, number of pages being, you know, the API, if you search for monsters, it's probably going to have more than a single, than a page or two of content for you, so it kind of spreads it out. So 20 pages of content from the API, pages here being referring to JSON entries, not actual physical pages, but the concept of it, and the number of iteration being 100. So it's a pretty large sample for this contrived bit. But the sync on average takes about, 1 second, and then this takes about like 0.3 seconds for the async. And, being that we ran this multiple times, there shouldn't be a lot of outliers here. This should be the rather consistent case for whenever you're using async versus sync. And it's really dramatic. I know my voice doesn't indicate it, but when you think about all the requests you have to run a web service like Google or Facebook or Amazon or all these other things, if you're spending a bunch of time just waiting on requests to be cleared and no actual CPUs work, you can take these numbers and multiply them times the number of applications you have, then times your cost per unit of computation. So 1 second of computation based on however you're running it. And this number really, really grows. So my challenge to you as the programmer is when you go and you start building services that call other services and do a lot of HTTP behind the scenes, start to think about if asynchronous computation can really help you, not just in Python, but in other programming languages as well. In Python, definitely look into async. Definitely learn about it and try to see where it can help you get what you need.